Hi everyone, welcome to 10-1 Day 3. I'd like for you all to take a minute to read over these first notes that we have right here for you. So take a minute, pause the video, read through these, and then come back. Okay, welcome back everyone. Let's start off with question number 1. Find the fifth partial sum of this rule right here, a sub n equals n squared minus 3. So if I'm finding the fifth partial sum, what I need to start with is n equals 1. And I'm going to find the first term, a sub 1, by substituting 1 for n. So 1 squared minus 3 is equal to negative 2. Now I'm going to find a sub 2 by substituting 2 for n. So that's going to give me 2 squared minus 3, which is 1. And I'm going to continue moving on in that same pattern. N equals 3, which is 3 squared minus 3. That's 6. If I wanted to find the fourth term when n equals 4, that would be 4 squared minus 3, which is 13. And the fifth term gives me 5 squared minus 3, which is 22. Now I'm going to stop here because they asked for the fifth partial sum. Well, the fifth partial sum means take the sum of the first 5 numbers. When you plug n equals 1, n equals 2, n equals 3, n equals 4, n equals 5 into the rule. And so all those numbers were negative 2 plus 1 plus 6. Why is that not working? Plus 6 plus 13 plus 22. And when I take the sum of all of those numbers, I get 40. So the fifth partial sum of this rule was 40. Perfect. All right, let's take a look at question number 2. Number 2 is also asking me to take a partial sum, except this time we're using sigma notation. See that sigma right there? So we're using sigma notation. We're always going to start by plugging this number into our rule. This is the rule right here. So when n equals 1, I would get 1 squared minus 1. And 1 squared minus 1 is 0. For a sub 2, for n equals 2, I would have 2 squared minus 2, which is 2. Then I'm going to do, when n equals 3, 3 squared minus 3. That's going to give me 6. And the last number I'm doing is n equals 4. Why? Because that's the top number right here. So I'm going to plug in 4 into my rule to get 4 squared minus 4. Oh no, 4 squared minus 4, which will give me 12. And so I'm looking for the fourth partial sum, so let's add up all those numbers. 0, 2, 6, and 12. If we take the sum of all those, we should get 20. So 20 is the fourth partial sum. Now, the difference between questions 3, 4, and 5 and things like questions 1 and 2 is I'm working backwards now. Now I want to write it in sigma notation. So I want sigma, and I need some type of a rule for these 1, 2, 3, who knows, however many terms that we're adding together. All right, well, I noticed that there is a fraction in each of these, and I noticed that 5 is in the numerator of each of these fractions. And did you guys notice how we have 1, 2, 3, probably going to go on to 4, 5, 6, 7, 8, 9, 10, all the way up until 15 right here. So I need to come up with some type of a rule. And the rule that I can come up with is 1 plus n. And so in order to get this first term right here, n equals 1 in that first term right there. And in order to get the last term in my sequence is 15. So I'm just going to put a 15 right here. So this is the rule. And if I plug 1 in for n, I'd get the first term. There's the first term. If I plug 15 in for n, I'd get the last term on there. Why don't you guys go ahead and take a few minutes and try questions 4 and 5 on your own. And then when you come back, I'll give you guys the solutions to these. Okay, let's go ahead and go through the answers to questions 4 and 5. Keep in mind, in number 4, this 1 is really a 1 over 1. I could rewrite it like that. And there's actually a couple different ways I can write this in sigma notation. Did you guys notice this is 2 to the 0 power? This is 2 to the 1st power, 2 to the 2nd, 2 to the 3rd power, and this would be 2 to the 7th power right there. So one way to write this in sigma notation is I'm taking the sum of 1 over 2 to the n power, and in order to get this first term right here, I would have to let n equal 0. And in order to get this last term right here, n would have to equal 7 on there. So there's one way to write this. The nice thing about these are, usually there are a lot of different ways to do this. Here's another way to do this. What if I started with n equals 0, all the way to 7, and my rule was 1/2 to the n power. That would also give me all of that. I could also do sigma notation, n equals 1 all the way to 8 of 1 over 2 to the n minus 1 power. So for this one, I had to start with n equals 1, not n equals 0. And then one other way to do this would be 1/2 to the n minus 1 power. We would have to start, we would have to start with 1 and end with 8 on there. And now here's the last one. So this last one, we're asked to take the sum of this infinite series right here. So the first thing we're going to do is sigma notation. I know that I'm going to take the sum all the way up until infinity because we have these 3 dots right here. It's not stopping at a specific number. Up on top, did you guys notice I have 1, 2, 3, 4. So what if I started with n here? And then this would have to be 1. 1, then plug in a 2, plug in a 3, plug in a 4, and the denominator just increases by 1. So there's an answer to question number 5. All right, now you guys are going to try quizzes. I will send you the code in the update. Have a great day.